OpenStax College Algebra student, this video is for chapter 7.1. We are into a section where we look at solving systems of linear equation. So in a way it is easier because all the equations are linear, but we have to solve a system. What does a system means? A system means there is not just one equation that you need to solve, but you want to solve two or more equations, and each of the equation would have two or more variables. So to find a solution, you are to find a numerical value for each of the variables so that it satisfies all the equation in the system at the same times. So sometimes these are called simultaneous equations. Now, for these kinds of equations, because you have multiple equation, multiple variable, sometimes the system may not have a unique solution. So sometimes there are one solution, sometimes there are many solutions, and sometimes there's no solution also. So it doesn't guarantee to have one unique solution, just like a regular linear equation. So for a 2x2 systems, if it is a linear equation, so it turns out that there's three types of systems. One is called independent system, where the system has exactly one solution. Another one is called inconsistent, where there's no solution. And the last one is called a dependent system, where there's infinitely many solutions. So the first thing we want to do is, if someone write a systems of equation, you want to check if a particular solution is actually a solution, or particular variable numbers like is a solution. So let's see how we can check it. So remember the definition of something is a solution is it has to satisfy all the equations. So this is example 1. So I want to check if 8, 5. So now the way we write a solution to a system is we look at the variable. There's two variables, x and y. And depending on the location of it in the alphabet, x is before y. So the first number in the order pair would be x. And then the second is y. So we want to check if x is equal to 8, y equal to 5. Is it a solution? Meaning that does it satisfy both of them? So let's check 1. So we will say 5 times 8 minus 4 times 5. Is it equal to 20? Is it a true statement? So this would be 40 minus 20. That's equal to 20, right? And this is true. So 20 equal to 20. So if it is true, this set is a solution for the first system, but for the first equation. But for it to be the solution of the system, it needs to satisfy both. So let's check 2, plug in 8 plus 1. Is it equal to 3 times 5? 2 times 8 is 16. 16 plus 1, is it equal to 15? No. If it's minus 1, it might, right? So 17 is not equal to 15, so it's not true. So although this 8 and 5 is true for the first one, but it is not a solution for the system. It has to satisfy both. So we say this is not the solution for the system, only one. Okay. So officially, how do we find these? Right. So you can't do guess and check all the time, right? How do we find them? We say there are 3 methods if it's a 2x2 system. What does a 2x2 system mean? That means it's 2 variable and 2 equations. So because there's 2 variable x and y, it seems like you can actually graph each equation as a graph. So you can solve by graphing. The second method is substitution. And the third method is solve by elimination. So let's look at how we can solve by graphing. So solve by graphing, because you have 2 variables, so you can graph them. My graph is on the next page. So how do I? There's multiple way you can graph it. So this is a preparation stage. So the first is you graph both of them, right? So this is 1, this is 2. So for the first one, the easiest way is to build two numbers. So some people would just do slope intercept, like for the first one, maybe we can do slope intercept. If your intercept is good. So usually I would just do 2 points, okay? So x and y. Of course, if x is so now try not to build a table values that has fractions or decimal because you can graph it on the chart, right? So if I have x equal to 0, let's say for example I want x equal to 0, then your y would be 2y equal to 7, right? So y would be 7 over 2 is 3.5. This is not good. Why? Because you can graph 3.5 accurately. So don't use that one. You can also use y equal to change it into slope intercept form, right? So you can think about, okay, let me change it into y equal to mx plus b, right? So you can say 2y equal to negative x plus 7 because you minus x on both sides. And then you divide it by 2, divided by 2. So y equal to negative 1 half x plus 7 over 2. So this is not very good also because this is not accurate, not on the grid. So not a whole number. So when you graph it on your paper, you can't accurately write 3.5. So this is not a good method. If this is a whole number, you should do it. If this is not a whole number, you should not. You would use another method with building a table. So if x is 0, that's not good number because the y-intercept is the issue. You can build x is equal to, or you can do y equal to 0, right? If y equal to 0, x would be plus 0 equal to 7. X is equal to 7. So this is a whole number, so that's very good. Is there another one that you can do? Can I have y equal to 3? If y equal to 3, then I have x plus 2 times 3 equal to 7. So x would equal to 1, right? So you would try to write as x-intercept form first to see if you get good number. If not, you want to build tables. When you build table values, try to make good numbers. So I'm going to graph this 7, 0 and 1, 3. So on this side, 7, 0, 1, 2, 3, 4, 5, 6, 7. And what was the other one? 1, 3, right? 1, 3. 1, 3. 3. 7, 0. So we have 2. I don't graph it really well. Is there a line that I can graph? So, so like that. So this is line number 1. And then we go back to graph line number 2. So for line number 2 is 2x plus 6y equal to 12. Can I use y-intercept form? 2x plus, so 2. 2x plus 6y equal to 12. Can I change it into y equal? So let's see. So, well, actually, the whole thing can be divided by 2. Do you see that they're all divisible by 2? X plus 3y equal to 6. Maybe it's easier. Okay, so minus x, 3y equal to negative x plus 6. Divide by 3, divide by 3. Do I get a good y-intercept? Yes. Y equal to negative 1/3x, negative 1/3 x plus 2. So I would just use this instead of building table. So it really depends on the case. So y-intercept is 2. Slope is negative 1/3. If not, you build a table values. But you want to build a table value where you have whole numbers. So 2, 1, 2. And then down 1, run 3. Right? Down 1, 1, 3. So you would have So it seems like maybe they would intersect here. So the two lines will intercept, and it would be, I think roughly 8 comma negative 1, right? Is that right? We can also use decimal to check answer. So let's check with decimal. But please do it by grabbing it by hand first so you know how to get it. Let's get this away. It's for so basically you 2y equal to 7, and then 2x plus 6y equal to 12. Do we get that? Click on the point of intersection. Oh, actually it's 9. So 9, negative 1. You can see that if you grab by hand, sometimes it's not accurate. Yeah, so we have a 6 comma 0. We have these. It's actually negative 9. So after you grab it, the point of intersection, so I should change it. I should change it to 9. Because, grab by hand is kind of hard. So the answer is the number that satisfies both systems is 9 comma negative 1. So solve by graphing. You can use decimal to check answer. Solve by substitution. Solve by substitution would be you have two systems, you have two equations, not two systems, you have one system. And if one of them has a coefficient of 1 or negative 1, you can just solve for it in terms of the other one and plug it in. So for example, I see x has a coefficient of 2. This has a coefficient of 1. These are not. So this is the one that I want to solve for. So you say, it has a coefficient of 1. I'm going to use it. So if I take out 2x on both sides, I would have y equal to negative 2x minus 5. And I'm just going to pretend that I know it. That is negative 2x minus 5. And substitute to the other one. Do not substitute back to yourself, right? This is from equation 1. This is equation 2. You will say substitute to 2. So if you substitute back to this, that's nothing. So you will say 3x plus 9. 9 what? Y is negative 2x minus 5 equal to 0. 3x plus negative 18x plus 45 equal to 0 after you distribute, right? And then I would have negative 15x combined like term plus 45 equal to 0, or negative 15x equal to negative 45 if you put the 45 on the other side, and then you divide, x would equal to 3, right? After that, then you say, well, I need y also, but y is here, right? So substitute to y equal to negative 2 times 3 minus 5. So it will be negative 6 minus 5 equal to negative 11. So your answer is x is equal to 3, y is negative 11. So this is the answer. So you write it as an order pair of x, y. So this is the second method. So I'm going to do a second video for the third method, which is solve by elimination, or we call it solve by addition.